Hey everybody, it's Dustin here with DP Alternative Energy Designs. And remember to read carefully my 9 steps for defeating the power brokers, the rich elite, and the leaders of the New World Order and the World Bank. 9 steps to defeating them and taking back control of our economy and our society. An all-important thing should be our main goal is to get control back of our lives and to end this financial slavery that most of the world has become corrupted into. So, I want to talk a little bit about the latest projects I'm working on. I haven't done a whole lot of videos in the past few years, kind of melted away in the background. It's not because I haven't been busy, it's actually quite the opposite. It's because I've been extremely busy working on some very pertinent projects that will help you and me and everyone else who is looking at open source information and trying to take control of their lives. Some of this information I'm sharing here publicly, working on projects to achieve these goals. So one of the major goals is to take money away from the World Bank financiers and the power brokers of the world who get a big portion of their money from energy profits. And for me personally, the easiest way for me to attack that aspect of the cancer that has grown in our society is to reduce our dependency on petroleum products, not only to stop funding terrorism, but also to direct money back into the United States, both nationwide and locally, using energy sources that are local and that are within the confines of the United States of America to bring the power back to the people. So one way to do that, there's several ways. There's wind, there's solar, there's geothermal, there's tidal, there's all those options. But one option that I've been particularly focusing on these past few years is cellulose ethanol and biodiesel from vegetable oil and other plant products that can be burned directly in a diesel engine. So hence I've been focusing on diesel applications as of late. Still working on the cellulose ethanol production design, but that's requires a lot more research and quite a bit of funding. Getting into the biodiesel sector is, I found, a lot less expensive and a quicker route to achieving some of the short-term goals that I have for my company and for me personally. What I went ahead and did is I purchased the best diesel passenger vehicle that you can get in the United States, as far as I'm concerned. And of course, some people will argue, is the Volkswagen Jetta and Golf TDI. So I went ahead and I got a Jetta TDI here. Of course, I got an R32, but that's gas powered. So here it is, the 2-liter TDI diesel engine. It's a 5-speed manual. So I did not get the automatic. I got the manual because I think it's more efficient, get better mileage, lighter weight, plus I'm not a big fan of automatics. So I steam cleaned it up a little bit. Nice little engine. So these cars go for probably $4 to $8 grand depending on the shape. Now you see here, it's evident some body work being done here. What happened is this particular vehicle got creamed in the right rear quarter here. Totally stuffed the quarter in from here all the way to right about where my hand is. So this whole section right here was completely obliterated. I got the car really, really cheap. A quarter of the cost of one that hadn't been damaged. I cut along here, and I had to cut right along here, and I also had to cut exactly right here. I'm still doing some body work there, you can see. And you can see, well, you can't really see. It's actually right here where I cut the old damaged part. And as you can see, I've finished the install of the replacement quarter panel that I got off of a junkyard donor. So here's the interior. It's really nice leather and stuff. But I got the interior all back together. Everything lines up perfect. The door gaps are nice. Okay, so it's very important to get the body lined up. Obviously, you can see that door gap's pretty good. The axle was bent. I got a new axle. Redid all that, so the axle straight, wheels centered in the wheel well, all my lines, so you can see the trunk's all done and everything. Had to take the glass out, so the glass lines are good. Glass didn't touch it anywhere. Trunk line is good. So I did all the welding and fitting. Most of the cutting, believe it or not, was done not with a plasma torch, but with a Sawzall. Very carefully. It took me about 2 weeks to remove the old section here. It took me about 2 weeks to do it because I cut and measured very carefully. And then on the donor car that I removed this particular piece from, I measured that exactly to the damaged part, and the pieces fit pretty close together. Now, I've got some pictures and a write-up of how I did this repair on VW Vortex, where I also have my R32 build write-up. But one significant thing that made this an insurance write-off is, you can't see it anymore because of the inner fender well, but I actually had to, where my finger is, that's where the cut went through the frame. So I had to cut through the unibody frame rail and up through the trunk floor. And if you look under, you can see, you might be able to see, how that's going to show up. But there's the weld line in the trunk. So this was a total because of the fact that the damage ate into the unibody structure of the vehicle. And they determined that it wasn't worth the repair, so I got it at auction, wicked cheap. And that part of the damage is completely repaired, and I'm doing some upgrades, working on the brakes, and you can see over here, come over here, you can see I'm block sanding. The whole body's getting block sanded and painted. So another cool thing, along with the quarter panel repair, over here you see there's a hunk missing out of the fender. Really sucks, but here's the piece that I removed out of there. You can see it's pretty rusted. So I cut it out, cut this right out of here. I'm going to weld a new piece in. Alright, so there's that fit. Just cut a little piece of scrap metal out and fit it in. Pretty close tolerances there, so I can get a nice clean looking weld. Grind the weld down after I'm done. A real thin skim coat of Bondo will do it, because see, if you look here, it fits pretty good. So, a little bit of tapping, a little bit of grinding, that'll be a nice piece of fresh metal there. Hammer out the arch there. Make sure it has a lip that goes all the way underneath, just like the factory. So, a little bit of welding, a little bit of grinding, 10-15 minutes of welding and grinding. And this is what you get. It's pretty good. A couple little metal flaws right there, but those are indentations, not outcroppings. So that's where the skim coat of Bondo will come in. But for all intents and purposes, that's a nice solid repair. Good seam all the way down through there. Matches the arch nice. Yeah, that should work pretty good. Stuff like that, save myself a couple $100 in buying a new fender. And I won't have rust cropping up later because it's a Bondo slap job, and it will end up looking like this right here. Right here is where I cut a piece out, welded it in, did a thin layer of Bondo over it, and it's looking pretty good. I still got to do a little bit of fine sanding, prime and fill, some fine sanding. Other than that, the body on this thing is really, really nice, in perfect condition. So the purpose of doing this vehicle is to get into the biodiesel field and build my own vegetable oil processor, where I'm going to take out the glycerin and all the other things that tend to damage a diesel engine, and I will be making industry grade, meeting the EPA spec biodiesel that I can run directly in this vehicle all year round, without heating elements, without special fuel tank in the trunk that's got either heated electrically or with engine coolant. Don't need any of that. The biodiesel that I'll be making won't gel in the wintertime any more than regular diesel will, and it will not create deposits in the cylinders and damage the engine at all, because all of the components of the vegetable oil that tend to gunk up and damage these engines will be removed through different processes, both chemical and mechanical processes. So along those lines, the purpose of actually me making this video is for this little guy right here. This is the next step in the H2EVair project. Some of you already recognize this is a small two-cylinder. It is a approximately 20 horsepower Yanmar diesel engine. Those of you who work with transportation industry will recognize this unit as being a typical unit that's used for message signs and other portable powers needed where there's no plug-in. This particular unit is a widely used design, and Yanmar is well known in those particular industry sectors because it is extremely durable, proven, will run forever. People ignore these things and let them run for months and months and months, don't even change the oil, don't do anything to them, and they just keep right on plugging. So this unit has a 10 kilowatt gen head. This is from Light Engineering, pretty small. Here's a way to scale it. There's my hand. There's the size. It's, I think, 8 or 9 inches in diameter there. It's really small. 10 kilowatts at 3,600 RPM. 8.5 at 3,000. Water cooled. Also, the gen head, water cooled. The Coda, if you remember from my previous video, has a built-in cooling system. It has a radiator and 2 fans. That was used for the battery management system and also the HVAC system. I believe I have to run the BTU numbers on the cooling system on the Coda, but I do believe that it will be more than sufficient to keep this engine and generator cooled. So I already have the cooling system all set. As you can see, there's no intake. I'm going to have to fabricate some, very simple intake device. And there's no exhaust, so I'm going to have to be fabricating an exhaust system to exit the vehicle. Going to put that in the back of the Coda, test it, get it running, and make sure that all the design parameters are up to spec, that this is actually, the 10 kilowatts is going to be enough, which it should be according to my calculations, given the battery size that I'm going to be using. And then transfer the complete traction drive and power system design into the H2EVair. And then, of course, moving on to the onboard capacitors to replace the batteries. So that's what we're looking at. Pretty freaking excited. So the deal on this is on the cheap. So between the Coda and this Yanmar, I'm still under 10 grand, which for me as a middle class income person, that's a budget that's achievable. You can get loans for that amount. You can save for years and save up that amount. You can borrow that amount. It's possible. This isn't going to be a $100,000 project. You can never correctly, you always underestimate. We are all optimistic, so a lot of times we underestimate the cost of a project. As of now, I've got a little less than 8 grand invested. By the time I'm done, honestly, it's probably going to be 15 grand, but my optimistic mind says I'd love to be able to do it for about 10. Now, I'm not talking finished product. I'm talking a rolling working model, about 10 grand. The finished project is going to be a lot more because the H2EVair is going to have a full restoration on it. It's going to have nice rims and custom interior, and I'm going to dump all kinds of money into that as the money comes in. Of course, so it's going to be a while. But over time, you save, you work, you figure it out, right? So that's what I've been doing here. This is what I've been up to for the past couple of years. That, and I'm still... Obviously, I haven't mentioned yet, but it goes without saying that I will be doing the HHO generator test on this Yanmar to see what kind of improvement I can get with some of my different HHO designs. We'll see if we can increase the runtime on this generator, and this is the perfect platform, as I demonstrated in my other gasoline genset tests, for an HHO runtime extension test. that it can be proven because you have a consistent lab type environment with very few variables, and you're able to measure fuel consumptions and outputs and power generation at a very close tolerance. So you can very accurately, as I demonstrated in a video I did quite a few years ago, calculate the net effect of the HHO system on your particular application. So there will be an HHO system on this as well, running with the biodiesel. Going to upgrade this. He's got a teeny little turbo back here, tiny little guy, right down in there. He's the little guy. So we're going to be boosting that, getting a bigger turbo, better wastegate. Probably going to put an intercooler down here. So many projects, so little money, so little time. But hey, it will happen slowly but surely. Putting these things together. The goal here is to get completely or virtually completely, because you're still going to have to run oil in a crankcase, but we're talking about almost completely freeing ourselves from petroleum products and switching to fully renewable, carbon neutral, affordable fuel products that can meet our transportation needs without range anxiety and without undue or overdue maintenance. Now, the maintenance on this EV project with this Yanmar is going to be insane. I've got to check the owner's manual for the maintenance frequency on this little generator. I know on my regular car, like something like this, I would change the oil every 3,000 miles. If I'm running full synthetic, maybe I'd go 4,000. I'm going to bet we're going to at least double, maybe triple it's going to be more. Obviously, this is done for hours of runtime. So the mileage frequency of maintenance is going to be just insane. I mean, the only thing I have to do to the vehicle is brakes and tires, pretty much, and this occasional, oil change, maybe twice a year. I don't know. I'll have to figure out the math. I haven't done that yet. Where did I find this? Big question. Found it on eBay. It was a surplus unit. A guy got a bunch of them, bought a trailer load of them, I guess. Normally, these, I think they go for around $2,500 as it sits. I paid significantly less than that. The message I'm trying to convey to the general public here, between this vehicle, which cost a quarter of what it blue books for, okay, because it was wrecked, and this, what I'm demonstrating, I still have less invested than most people in a decent used car. And I'm going to have a wicked awesome TDI that looks great and runs wonderful. This thing runs great. So the point that I'm trying to convey here is that using your skills that you possess, if you are willing to put some work into projects, into items, you're willing to hunt and search and not just always buy brand new, flip open the wallet and spend quickly. Okay, if you're willing to not do that and to look and to wait and to search around and to fix things, it's fixable. You can do your own work and make things nice. You can save a lot of money. And I mean, did I mention a lot of money? Okay, that's what I've done. I mean, the shop that I'm filming this in, most of this stuff was free, that I just picked up at lumber yards and stuff I found on eBay real cheap, stuff at yard sales, okay? So that's the way I operate, and that's the way we all as a society need to start operating that way. We need to start doing things for ourselves, doing our own maintenance, doing our own work. Instead of buying new, give life to old things, rebuild things, fix stuff. Take something that's a piece of junk that's a write-off and make it into something awesome. I've spent my whole life doing exactly that, and that is how I end up having nice stuff, even though I don't have a lot of income. I don't need a lot of income because I have welders and I have a paint gun and I've got some basic, metalworking and mechanical skills. And what I'm saying to some of you out there, be you men or women, you have hands and fingers and brains just like I do, and you can do this kind of stuff as well and save yourself a ton of money. Yes, it takes time, but it's a trade-off, I mean, if you don't have a lot of money, make the time. if you do have a lot of money, still make the time. You can take the money you save and put it away for, survival fund for when the crap hits the fan. Be ready. So it's, be smart with your money. Do a little extra work. Think ahead. That's the message I'm trying to convey here. So that's the update. That's what's going down. That's what we're working on. Biodiesel, Yanmar, 10 kilowatt, going into the H2EVair. Big progress. And I can't wait to share the next iteration of updates with you. Still got a little bit more money to spend and a whole lot more work to do. Get this Yanmar in the trunk of that Coda. Get a sound box made up. Get some things running. Get that Coda moving. And we'll see where it goes from there. What am I going to get for mileage? Well, I've done some math, and I've got a good idea, but I don't want to let the cat out of the bag. I'm going to wait and let the numbers speak for themselves. I'm not going to make any public predictions, although privately I have a prediction, and if I'm correct, it's going to knock your socks off. All right? So that's all we got. Dustin, DP, Alternative Energy Designs. Happy testing, everybody.